In this video, you'll learn how to calculate the average atomic mass for an element. These are the masses found on the periodic table. For carbon, it's 12.011. For magnesium, it's 24.305. Scientists use a device called a mass spectrometer to figure out these averages. We'll use a computer simulation to figure out how these averages are measured. We'll also go through how to use the equation below. This is a computer simulation that lets us analyze samples of atoms found in nature. In this chamber here, we have 1 million atoms of carbon that were found naturally in nature, and they've been put into a mass spectrometer. A mass spectrometer is a device that lets us measure how many of different isotopes are found in a sample. These atoms have been atomized and ionized. So atomized means they've been turned into individual atoms that are bouncing around here, and they've been ionized, meaning electrons have been knocked off and they're now positively charged. The positive charge is important because when they go through this chamber, they'll pass through electromagnets, which will then deflect the atoms downward. And the heavier the atom is, the less it will be deflected. The lighter the atom is, the more it will be deflected. And in that way, the detector can determine how many of each type of isotope are in the sample. But we're going to go ahead and release these atoms, and they're going to go through the mass spectrometer, and you'll see how they get deflected differently. Most of the atoms got deflected more and did not go as far on the detector. Most of them were carbon-12 atoms. That's 98.9% of the sample. And the mass of carbon-12 is 12.000 atomic mass units. 1.1% of the sample was carbon-13. And carbon-13 actually has a mass of 13.003 atomic mass units. So very close to 13, but not quite 13. We can repeat this again for magnesium. We'll do 1 million atoms. And when we release those, we see that there are actually 3 isotopes that are commonly found in nature. 79% of the magnesiums are magnesium-24 with a mass of 23.985. 10% are magnesium-25, and 11% are magnesium-26. So let's go ahead and do a calculation for the carbon isotopes. We saw from the simulation that 98.9% of the carbon isotopes were carbon-12, and 1.1% of the carbon isotopes were carbon-13. This is what it looks like when we plug in our values into the equation. However, we don't want to use percentages out of 100. We want to use the percentages as decimals. So for the percentages, move the decimal point over 2 places, or divide by 100. When we put into our calculator 0.989 times 12.000 plus 0.11 times 13.003, we get the average atomic mass of carbon, which is 12.011. This matches what we see on the periodic table. For magnesium, 79% of the atoms were magnesium-24. They have a mass of 23.985. 10% of the atoms have a mass of 24.986, which is the mass of a magnesium-25 atom. 11% are magnesium-26, which has a mass of 25.983. Again, we have to multiply these masses by the percentage as a decimal. 79% becomes 0.790. 10% becomes 0.100, and 11% becomes 0.110. When we multiply 0.790 times 23.985 plus 0.100 times 24.986 plus 0.110 times 25.983, we get 24.305. Again, this is a match for what we find on the periodic table. Using this same method, we can find the average atomic mass for all of the elements, just as long as we know the percentage of each isotope and its mass. If you like this video, don't forget to hit that like button and subscribe.